Hi, my name is Cody Mack, and today we're going to go over the 5 things you need to know about air problems in your hydronic systems. One of the first signs that you'll notice that you have air problems is going to be the noise, the gurgling, the rushing water noise going through your fin tube baseboard. It's going to be annoying to your customers, and it's no joy for you either because it will lead to a slew of other problems. So when you've got air in your hydronic system, that air will have oxygen. When oxygen comes in contact with ferrous materials, you're now dealing with rust and corrosion. Your steel piping, cast iron boilers, and circulator volutes will wear and fail prematurely. Now, in extreme cases, air can actually cause a no heat scenario. The fluid in your hydronic system carries heat from the boiler to your heat emitters like a conveyor belt, and your circulators are designed to move fluids like water or glycol. They are not capable of overcoming large air pockets, and then this is usually what is referred to as an airlock. No circulation means no heat and a cold customer. Airlocks can also happen in your circulator as well. With most circulators incorporating a spring-loaded check on their outlet, they have the ability to trap the air, filling up that volute. So when your circulator turns on, that means no flow. In some of your larger applications, air can also cause cavitation. This will make your circulator sound like it's chewing gravel and lead to its early demise. You should also know that air has the ability to get into your systems with a lot less effort than you would think. Many have seen the effects of osmosis, where air and oxygen enter a closed-loop hydronic system through PEX piping with no oxygen barrier. Now, what about air vents, though? We all assume, and understandably so, that air vents and air separators are there to remove air from your system. What you may not realize is that under the correct conditions, they can also allow air back in. This is where you will always hear about pumping away, and this is referring to pumping away from your expansion tank. By pumping away from the expansion tank, the differential pressure created by the circulator will be actually added to the static fill pressure. On the other hand, if you pump into your expansion tank, your circulator's differential will be subtracted from that static fill pressure. This is because the expansion tank is your point of no pressure change, and by pumping into it, you can create a negative pressure, allowing air vents to bring air back into your system. Air problems can be dealt with and even eliminated, but I would caution you because not all air removal devices are created equal. You need to be looking for a high-efficiency air separator. These will go far beyond the capabilities of the air scoops of yesteryear that should only be used as paperweights these days. A well-designed coalescing type automatic air separator placed appropriately in the system is going to be your best bet to provide high-performance air removal. Air is going to be best captured and eliminated at the hottest point in your system. This is because air is less soluble at higher temperatures. The combination of a large bell-shaped low-velocity chamber combined with a quality coalescing media will help to slow down those microbubbles, catch them, and bring them together to take one last ride to the top of your air separator and out through the air vent. Now, a central air separator is always going to be your best bet. However, in many cases, additional air vents can aid in complete air removal. High points throughout the system can actually trap air, preventing it from returning back to the central air separator. In many cases, you'll find air vents included with devices you're already using. Classic examples are going to be radiant manifolds, fan coils, and even the tops of your buffer tanks. Over long periods of inactivity, like the summer months, air will migrate to the highest points. So allow your system the opportunity to catch and eliminate this air by using these air vents. Caleffi air vents also have a number of interesting accessories available, like service checks, anti-siphon caps, hygroscopic caps, and thread adapters to allow for remote discharge. I just want to finish with a few features that set a Caleffi Discal air separator apart from our competition. The process of high-performance, high-efficiency air removal comes from sound engineering. It's easy to see when comparing that our air separators are usually quite a bit wider. The size and the shape of that body is going to create a low velocity zone to slow that fluid down and make sure the coalescing media can snatch up all those microbubbles. The glass reinforced nylon coalescing element that you'll find in our smaller brass models, as well as the stainless steel element in our larger flange models, is designed and shaped with all the sharp edges to collect all those air bubbles. They're also designed to handle all types of fluids, even aggressive, low pH glycol solutions. On the top of our air separator is going to be a pinned float assembly and stainless steel linkage to ensure snag-free movement and reliable operation. Top quality forgings and castings are going to ensure a state-of-the-art looking and performing component across the entire size range. But perhaps the biggest feature that installing contractors and service technicians will love is how easy our products are to service. In the event that you do get any debris in the air vent assembly causing it to leak, you can easily remove the cap and float, clean it up, and put it back into service. Thanks for joining us on another episode of 5 Things You Need to Know. Again, my name is Cody Mack, and we hope you tune in for the next one.